Good day everyone, welcome by the webinar Simplifying DMX, everything you need to know. Together with me, Heino de Heijde and Stefan Wijdeven, we're going to talk for 30 minutes about a very interesting topic, and that is DMX.
Thank you, Heino, for introducing us. Let's speak about why we're doing this webinar and what drives us to bring the latest information on DMX, how to be successful in our 30 minutes webinar. Starting with the why, because of the interoperability, we as eldoLED are, as a driver manufacturer, always between the control system and the luminaire itself. So we're the linking pin between the control signal from the lighting control system and the light output of the luminaire. And because most of the times eldoLED is a specification-driven brand, because we are the industry recognized leader on dimming performance from 100% all the way down to dark, we're basically the experts on DMX, and with our wide product offering, we enable ourselves to have a suitable driver for every application which is available in the market.
So that we have multi-channel solutions, we have constant voltage solutions, we have constant current solutions, and multiple operating windows and multiple power segments.
Indeed, from linear drive to power drive, from AC products to DC products, in our portfolio on DMX products, we offer it all.
Okay, good news. So the topics for today are the introduction to DMX, of course. Then we go a little bit deeper into DMX itself. How does the mechanics work on that cables? Next step is designing for success. What do you need to do before you enter a big project with DMX? What is the do's and don'ts of DMX? The product offering by eldoLED, what kind of products we have, what could be helpful in your project, and of course, as last but not least, is the Q&A sessions. I would say you as a guest, as a participant, please use this opportunity to participate in the Q&A session at the end of the webinar. So take notes, ask those questions.
Yeah, you can fill in all your questions already during the webinar. They will be logged, they will be in our system, and at the end of the presentation, we're going to review every individual question and try to answer them as best as possible.
So let's start.
Starting with the introduction to DMX.
History.
Historical.
Where did it all begin?
It all began basically in the 80s when all the theater equipment had centralized DC dimmers, dimmer packs, dimmer racks, which were all based on proprietary control systems. The link between multiple different vendors was almost impossible in those days. So the UCIT organized in 1986 an event where all the big players in the market were joining forces together to try to come up with an industry standard, which was basically allowing them to link those proprietary control systems together so you could build a network with multiple different brands all operating from the same control desk.
So in the time that they use a strand lighting dimmer pack, a big one, they can only use it then with a strand lighting console.
Indeed. So what you saw in those days is that you could only stick to one single brand. But in those days, you would only have one or two different type of luminaires because they were all halogen. Remember the Parkens from those days?
Yes, absolutely.
The change to nowadays is that we introduced moving into the lighting, we introduced color into the lighting, dimming capabilities, and all kinds of different effects are nowadays controlled using DMX. And the biggest difference is that it changed from centralized dimmers to decentralized luminaires, which all had their individual controls integrated into the luminaire itself.
So what industry standards then are driving that DMX 512 quest, so to speak?
Well, the multiple different international standards, which all refer to DMX. So a well-known name in the industry is the UCIT. Next to the ESTA, the ANSI, all big, mostly North American organizations that are driving that DMX standard. And however, they all have their own different standard written, they all refer to the same application and the same implementation of DMX 512. So the ANSI DMX standard is similar to the ESTA DMX standard, and maintained by different brands as a working group. They all work together seamlessly because of the fact that they're all based on that same standard, which is founded in the 90s somewhere.
And as we are an industry standard, we are absolutely interoperable with the real DMX 512 standard.
Yeah, indeed. We follow those standards as close as possible in such a way that we always maintain that same implementation to be compatible with everyone in the industry.
Good news. So this is the next slide, introduction to DMX. But I now see a TV broadcast company screen, and I see a TV decoder. It's digital, it's DVB, and I see a television screen with channel 3 news. What does this has to do with DMX then, if I may ask?
Well, if we go back to the basics, we need to explain how that system works. And if you look to a TV broadcast company today, they are broadcasting 30, 40, up to 100 different TV channels. And all those TV channels are going with the same cable to your house. That cable is entering your DMX or your TV decoder. And on your TV decoder, you use your remote control to set a certain channel, and that single channel is sent to your television screen. But at the same time, your system is receiving all those 40 different TV channels, and you're simply selecting the one you want to see on the screen.
Ah, now I see the connection. It's like a start address on your fixture then.
Indeed, because if we do the same for a DMX application, it all starts with the lighting control desk. That lighting control desks send out the dimming signals for all the luminaires which are connected to that control desk. That single cable goes from the lighting control desk to the luminaire, and on the luminaire itself, we set the address in such a way that it responds to that particular channel. And the channel is that link to that TV broadcast station. And in the end, your luminaire is bringing you the illumination based on that particular channel address or that dimming value that's been sent out on that particular address.
So it's also possible when you have 30 fixtures, they all listen to start address number 1 then?
Yeah, you can put them all on the same address, the same as in your house. You can put all your televisions to the same channel.
Got it. So the DMX protocol, how does it look like then? What is the data flow in such a system then?
Well, this screen might look a little bit complex, but it actually is pretty easy to understand, and it's pretty easy to explain. If we look into a DMX signal, it's a digital signal.
Yeah.
So it's containing zeros and ones. Looking into that particular signal, it looks like a train. So when you start your DMX installation, when you start sending out that data stream, you first start with the break signal. The break signal is the signal that tells all the connected luminaires, be ready, there is a new data stream arriving. At the moment that the luminaires are receiving the mark of the break, they're starting listening to that data stream on the cable. And it all starts with the start code. The start code is the identification, which is all zeros in a typical DMX lighting information stream. But you could also have your manufacturer-specific codes that is telling the luminaire only to listen to that information if the luminaire is from that particular brand. So you could do some proprietary stuff over the DMX line.
So the fixtures of that particular brand will only listen to that train?
Yeah, indeed, because all the luminaires are programmed to ignore everything else than zero in the start code.
Okay, and how many trains pass that line then a second?
Well, it's one long train. So having that start code being all zeros, we start with the data bits, the channel data. And the channel data is containing the dimming level, which can be from 0 to 255, which is 8 bits. Those are the data bits. And that channel information starts with a start bit, which is a 0. Then it's followed by 8 data bits.
8-bit.
8-bit. And then it's ending with 2 stop bits. And then you have the information from channel 1. Directly after that, you get the information from channel 2 up to channel 512.
And then the train starts all over again.
And then the train starts over again, we're in the idle state, we receive the break again, and then we're going to do the same sequence again. So you get 512 individual dimming levels directly sent after each other.
And that is, I can recall, 44 times a second.
Indeed. A typical update frequency of a DMX frame rate is 44 hertz, because that typical frame is taking 22 milliseconds in total to transmit all that 512 DMX channels over the cable.
Okay, then I have another question. Now we're talking about 8-bit signals. It's also possible that our drivers can also respond on a 16-bit signal. What is this? What does it mean?
Indeed. The signal is not different. It remains the same data train.
Okay.
The only difference is that we tell the driver to listen to 2 channels at the same time. And we combine those 2 channels to be one bigger channel. So you get, instead of 8 bits, you get 16 bits. So from a dimming level perspective, instead of from 0 to 255, you go from 0 to 65,535. That allows you to have a much higher resolution in step size.
Okay. I think that I've seen in the time I was doing as a lighting engineer, when we used the moving heads and those scanner heads, you can also select 16-bit, but that was because of those moving heads had to turn 720 degrees. And if you use 16-bit, all movements and dimming was much more smoother, but also if you want to rotate 720 degrees, 250 steps are not enough to do that smooth. And that's the reason why they allowed to combine the channels to have a higher resolutions for the applications that required it. Yeah, okay.
But a single luminaire could combine 2 channels.
Yes.
Another luminaire can use only 1 channel on that same signal train. So you can mix that in the same data signal because that signal remains the same.
Okay, so that means that when you are having a control desk, you have to tell the control desk or ask the control desk to do, hey, these channels I want to do on 16-bit, and these channels I have to do on 8-bit, and that's really important that you set up your driver accordingly as the lighting control desk requires.
Indeed.
Okay,
Indeed.
so those 2 you have to match
fully correct
on the project. Okay, so DMX explained what it has to do then with RS485 serial communication.
The DMX protocol, which is the lighting language, is based on RS485 from an electrical perspective. And RS485 means that the signal is balanced. How does that look? If you look into a typical DMX signal, which can be a 1 or a 0.
Yeah, this is a part of the data train. Then.
That's a part of the data train. I've now only showed 4 pulses, but it is an endless amount of pulses. In DMX, you have 2 wires. You have the DMX positive and you have the DMX negative. So what we do with that signal, the DMX positive wire is receiving that same DMX signal.
Yes.
And the negative wire is receiving the inverted version of that same signal. So where the one is positive, the other one is negative. Because of the fact that those are the opposites of each other, if we then apply a signal disturbance on the cable, that same disturbance or interference or whatever spike you get from a noise perspective on your cabling is affecting both signals the same way.
Yeah.
So it's lifting the pulse a little bit higher and also here the low end a little bit higher. You get the same peak on the same 2 channels.
Okay, then I have a question. What is the voltage peak between 0 and 1 then?
It's roughly about 5 volts.
Oh, that's USB level, though,
Yeah,
so that's quite low.
It's a very low voltage level signal. So mains influences might interfere a lot with that low voltage of the cable. That's the reason why the cable is shielded as well.
Okay. So you need 3 conductors then to do DMX wiring properly.
Indeed. You have the positive, the negative, and the shield. And the shield is very important because in the end, in the luminaire, we're combining those 2 signals. We subtract them from each other. And in the end, you get that same signal because the noise that was applicable in the cable is now subtracted, and in the end you get that same clean signal back in the luminaire.
So that means when one of the conductors is failing, you can end up with a huge disaster with all kinds of flickering and flashing of fixtures or whatever.
If one of the signals is losing, so imagine the minus is losing, then that balancing of the signal is no longer there. The subtraction will be subtracted by 0, which means you get that same noise on the line, you get that in your fixture, and then your fixture might respond different.
Yeah.
Because there is no error correction or checksum available in DMX. Every signal that's on the line and received by the luminaire will be visible in the light itself.
Clear to me. Signal reflections. So this is an important topic, I can imagine. On the left side, we see a perfectly square waves, and on the right side, we see something totally different.
Yeah. The signal will never look as clean as this. So this is the ideal situation where the signal is 100% according specification. But when you introduce cable lengths and capacitance and all kind of loads on the line, it will always interfere the signal.
Mm-hmm.
The positive thing is, as long as the pulse is high enough to be recognized as a 1, it doesn't influence. And as long as it's low enough to be a 0, there is no issue by having slight peaks on that DMX signal. But from the moment that the pulse is getting into the low end, where it's recognized as a 0, from that moment on, you get interference on your DMX signal. And this one will still work, but there are some examples which are way more dramatic because of the fact that the wiring is done wrong.
Okay.
So looking into that DMX network, what do you see here on the screen?
This is a typical DMX system with wiring. DMX controller, one wire going to every fixture as one line, and at the end of the line you terminate the line with a resistor.
Indeed, but what you see here is you have always only one controller, and you can have multiple luminaires on that same cable. But that cable is always one long run of cable. So that cable is passing every luminaire. So you cannot make a star topology, you cannot make T-taps. It should always be one straight line to avoid reflections and disturbances of the signal.
Yeah.
And that resistor at the end of the line is to close the line in a proper way, in such a way that you do not receive any echoes on your line. If you remove the resistor, you're basically shouting out in the cable, and the cable will get some echo, like you were in a tunnel.
Yeah,
you get your own voice back, and that will generate a quite strange signal on your DMX line.
Okay, so this is how it looks like when you magnify how it looks like. Eh?
Indeed, we're eldoLED, we are a driver manufacturer, so a luminaire doesn't look like the picture we showed before, but this is a typical way of wiring a DMX driver. That cable comes from your control system, so you have the positive, the negative, and the shield. It's entering the first driver. On that first driver, you're connecting the cable that enters the second driver. So however this might look like you have T-taps on your line, you actually have one long piece of cable. And at the end, you put that 120 ohm resistor on the last luminaire in such a way that the line is properly terminated.
And terminated means short circuit the line at the end between DMX positive and negative.
Yeah, that resistor is placed between the positive and the negative terminal to avoid that reflection in the cable.
Got it.
Cabling.
What's
the difference between those two cables?
So what I see at the first, it's the same average diameter, it's the same conductor diameter, it both has shields. I think the only difference is that the lower one has twisted pairs.
Indeed. The cable you see above might look like a proper cable because it has a shield and it has two conductors. But this is a typical microphone cable made for analog signals.
Yeah.
A digital signal has a high frequency rate and therefore requires that twisting in the cabling to have a proper signal distribution. So, however, from specs, those cables might look the same because they have the same conductor size, they have the same shielding, they have the same insulation, and the only difference is that twisting. But that twisting is very, very, very important to have a proper signal distribution on your DMX network.
I saw that same twisting also in Cat5 wiring. Cat5 is UTP, let's say unshielded twisted pair, so that's data cable. Now you can see that twisted pair is needed to transport data.
Yeah, a Cat5 cable can also be used for DMX because of the fact that it has twisted pairs inside, and that's required for that RS485 signal. So if you want to select a proper cable, you either need to look on the cable if it's suitable for DMX, but you can also look if the cable is certified for use for RS485. Because from an electrical perspective, DMX is exactly as RS485. So the cabling, as long as it meets the RS485 standards, is perfectly suitable for DMX as well.
Okay, what will happen then if you use a normal microphone cable on a small setup? Would it work?
On a small setup, on short cable lengths, that influence of the twisting is probably not very much. But when you make longer runs, it in the end won't work. So it might look from a development perspective, it might work at first time when you're installing all your equipment. But once you open your building, you turn on the Wi-Fi, you have cell phones in the building, you get way more noise in the environment. From that moment on, you get all kind of strange side effects because of the fact you use the wrong cable.
So it can happen that a cable between luminaire number 1 and 2 picks up so much disturbance that luminaire number 32 gives an error or a glitch or a flash or whatever.
Exactly. That cable, that signal is distributed from the control via every luminaire. So the luminaire at the end of the cable might be influenced because of the noise that's entering on the beginning of the cable. So the whole installation needs to be equipped with proper cabling without any star or T-splice connections in the cabling.
Good point.
Because looking into that signal, if we say we want to have that proper signal and we did the wiring correct, at the end the luminaires will all receive that correct data frame of the wiring. But if you remove that termination, you get the reflections, and then you get a signal that looks like this on the right part of the screen. You get the echoes in the screen, and now your luminaire is no longer be capable of recognizing that 1 and that 0 correctly, because that pulse is no longer according to timing that are set in the protocol of DMX. So these reflections are undesired, but maybe not critical and not visible in the installation. But at a certain moment in time, you get so much noise on the line that the luminaire is not capable of receiving that signal in the correct way.
Got it. And that decoding is done in the so-called transceiver module of the driver.
Indeed.
Okay.
Indeed. Yeah. Okay. So that resistor, however it's only resistor, is being the difference between having a clean signal with a resistor and having a echo and reflections on the line because of the fact that the line is not terminated properly.
So a 10-cent components can make the difference.
A 10-cent components will make the difference in the reliability of your installation indeed.
So other stuff on Design for Success. What you don't need to do is put more than 32 devices in a line without having signal booster, no star topology, no T-taps allowed. This will cause issues in the end. And the most important one is to use the correct cable designed for RS485 and or DMX.
True.
Absolutely. And
true.
Wiring?
That 32 devices is simply because of the fact that the transceiver has a certain load on your line.
And just 5 volts.
And the RS485 standard says that you can only connect up to 32 slave devices on your host controller.
Yeah.
If you exceed that number, you're exceeding basically the power that the transceiver, that the transmitting device can provide to your system. So if you want to hook up more than just 32 devices on the line, you simply need to add a signal booster, or you need to use a splitter and divide it over multiple lines.
Then there's another question. So a 4-channel driver is one device. Yeah. And if you have a 1-channel driver, it's also one device.
Exactly. Okay. So it's every physical device connected to the cable, indeed. And that may not exceed over 32. And yes, for sure, if you connect 33 or 34, it will still work, but you're out of spec of that standard. And that will, in the end, gives you trouble if there is too much external influences on that DMX line. Yeah. Best practice is always to use that cable specified for RS485 and use both wires and connect the shield properly. Without the shield, the signal is floating, the cable is no longer shielded because there is no ground level anymore. It will cause issues if you only use 2 wires. So that shield is even important as the data plus and the data minus wire.
Sometimes in a cabinet you see those, the UTP cable, some wires of the UTP cable are used, for the Cat5 cables are used to connect those drivers. Multiple drivers in a cabinet, and then you don't see any shielding. Can that give issues?
Well, as long as you have the 3 wires connected, it will work. Because of the fact it's a balanced signal, that influence in the noise is influencing both conductors. So if you have a typical Cat5 cable, they always use one pair of the cable for the data positive and the data minus, which are twisted together, and they use a separate pair, most of the times the brown pair, to act as the ground, the third DMX wire.
So the takeaway is use twisted pairs for DMX plus and minus.
Exactly.
Got
exactly. It. Yeah. And what people often forget is that if you want to equip a wall theater with DMX fixtures, make a plan up front. Because if you make a plan up front, you can draw the luminaires on the map and you can find the best way how to wire them.
Yeah.
If you simply start installing the first luminaire and pulling the cables to the second one, you're never making an optimized plan of connecting fixtures, but you also need to keep track on how many units you have connected to that cabling. If you do that on a map, it's way easier than doing it in the field afterwards. So designing for success means make a plan up front instead of afterwards, in such a way that you have a good overview where to put the signal boosters and where to put the signal splitters and so on.
Makes sense. So it's semi-easy to do, making a DMX plan, only to make sure that you follow the simple design instructions.
Exactly.
Thank you.
From an eldoLED perspective, in the last 4 months, we launched several new products, which are our new power drive products, where we have one here on the table, 50-watt devices with 4 outputs, a completely redesigned DMX interface, which is now optically isolated, which is way more robust and way more better performing as before. We have launched that product in a 50-watt U version, and next to that we brought a 50-watt A version with the strain relief and the 50-watt S version, which is available for inbuilt applications.
Okay, and I see it's a 4-channel device. Can it also be used as a 3-channel, 2-channel, or 1-channel?
Yeah, we can configure the device in such a way that you can enable or disable certain channels. So if you want to use a 4-channel product to act as an RGB product, you can simply disable that 4th output and use it as a 3-channel device.
So make a different profile in FluxTool or order a different CI code with our sales department, and you get the correct driver as needed.
Yeah, but you can also do the opposite. You can also say to the driver, I only want to use one DMX address, but I want to connect it to all 4 outputs. Okay. So I can connect 4 LED light sources to that single driver and act if it's just a 1-channel DMX product. With that versatility in programming, there's no reason to have a 3-channel product available anymore or 2-channel product anymore. It's just the amount of power that the device is supplying, and the maximum allowed amount of channels is 4.
Got it. And how many terminals are on that driver then for DMX?
For DMX, we have a 3-pole connector, the data positive, data negative, and the shielding. And because the fact that you need to daisy chain on the terminals, that might be a little bit tricky because you need to put in 2 wires in that same terminal. A best practice there is to use a wire for rule. So if you use a DMX cable, which is typically roughly 0.25 square millimeter, if you put 2 of those in a wire for rule, you can still easily insert them into the DMX driver, and you don't have the issues that the cables might short each other. So doing that up front means that you can connect the cables up front, add the wire for rule, and later on stick them in the driver, avoiding any shorts in the cabling.
So it makes sense. So you avoid T-taps and you have a secure connection, easy to produce your luminaire in. Okay, got it.
From a specification perspective, this driver can be used from 2 volts all the way up to 55 volts. So every available LED in the market can be connected to this driver, and you can freely program the drive current from 150 milliamps all the way up to 1400 milliamps. And it doesn't have to be the same for each channel. So you can put one channel on 700 milliamp, and you can also put the second channel on 900 or whatever drive current. So it doesn't have to be all the same. You can define it for each individual channel separately. Next to the forward voltage, it can be different on each channel. It doesn't have to be the same. It might be the same in a practical situation, but you can connect a 2 volt LED on output 1 and use, for example, a 36 volt LED on output 2.
Okay.
The driver is automatically regulating the power in such a way that both LEDs receive the correct amount of current for that particular LED.
And the output of all those channels at the same time will never exceed 50 watts? Is that correct?
Well, the driver has some protections inside in such a way that it's preventing you from overloading, but you need to design in such a way that the typical application is never exceeding that 50 watt power, because it's a protection and it's not a feature.
Got it. Yeah.
But there are multiple ways to avoid overloading the product. It's from connecting the right amount of LEDs, but if you connect too much LEDs, you can also use some settings inside the driver to scale the power in such a way that you're never exceeding that 50 watt of the driver.
Total flexibility of a mouse blade.
Exactly. And all that information you can find in our design-in guide, which is available on our website.
Yeah.
It might be interested to look into that design guide as well.
Absolutely. Good idea. So I think we covered a lot of the topics. Of course, you can follow us on Twitter or LinkedIn or on YouTube on our channel eldoled.com/experience. I think it makes sense to start with the Q&A session. If there are any questions, feel free to post them, and we're here to answer them.
Well, let's look at those Q&As.
Can I use Cat5 cabling for DMX? I think the answer is yes, except your Cat5 cabling is non-shielded cables.
Yeah, most of the UTP cables are unshielded because of the fact it's UTP.
Yeah.
But you also have the STP cable, which is the shielded version of the UTP cable. If you ask me, the best practice is always to use a shielded cable, because you might not be able to change that cabling in a later stage.
No, you can. Mostly you can totally forget it. So
the best cable is the RS485. Also allowed according to standard is a UTP cable, but take a shielded version in that case to avoid any issues going into the field.
Are there any DMX controller that eldoLED has tested or would recommend? I think we tested a lot of them.
Yeah, we have a light loop full of DMX control systems. We have Pathway products, we have Pharos products, we have Traxon products, we have Nicolaudi products. They are used all over the world, and they all stick to that same DMX standard. So yes, we're testing them all, but I cannot easily tell which one is the best or which one is the one to avoid, because they all have their own features and they all have their own functionality. So for an architectural application, maybe a Pharos controller is the preferred brand.
Yeah.
But for an entertainment or for a live venue, they might want to use a lighting desk instead of a show player. So as long as they're all DMX 512, they should all work exactly the same from a protocol perspective. So features can be different, functionality can be different, but from a signal perspective and compatibility with the eldoLED driver, they should all work as expected.
Clear. How does it come there is no more master-slave functionality for the new power drivers? Let's say the power drive 50 watts. What's the thing with this?
Well, originally we had a feature which was called master slave, and we had the so-called LED sync functionality. Yeah. But that LED sync functionality was a proprietary control protocol from eldoLED. It looked like DMX, but it was a little bit different from DMX. So where people were expecting that it was exactly the same as DMX,
it wasn't.
It wasn't. So we made the choice to be fully compatible and fully according to standard, and that was no longer allowing us to use that special features on that particular product, next to the fact that we had to remove that DMX out functionality to have a proper, decent DMX connector on the product, because there's not so much space.
No.
So we removed that LED sync out functionality simply to be compatible with the industry standard. And yes, there were some people using it in a good way, but we have seen many installations going wrong because people made the wrong assumptions and thought it was DMX.
Yeah, and then they came out on a project. They say, hey, where's the RDM capability? It's lost
exactly.
in
there were some negatives there, and that's the reason why we choose to be fully compatible with the standard and not doing anything else in the background. Is eldoLED providing any field support?
At this moment in time, no.
Well, before the COVID, we were traveling all around the globe to help people designing in the drivers in the correct way, but also avoiding the issues. And if there were issues on site, we were basically solving those issues from the site as well.
Yeah, so we learn, the customer learns, and the end user is happy.
Indeed. And where's all that knowledge coming from? Simply from experience. So I made all those experiences and all those mistakes myself as well.
So you're the only one that makes mistakes.
No, definitely not. But in the end, we'll go side by side together to a site.
Yeah.
And solve those issues together as one.
Yeah. So yes, there is support on site.
But I hope we don't have to go on site, that we can provide that same support before we even go to site, simply avoid it going wrong on the site itself. I'd rather do it in a lab than do it on site and fix it afterwards.
Are DMX LED drivers always with 4 channels? That's a good question. Yeah, we have multiple LED drivers. The power drive 50 watt has 4, but you can configure it any way you like it, as a 1 channel, 2 channel, 3 channel, or a 4 channel. And we also have some constant voltage products running on 1 channel. We have a US specific 30 watt 1 channel driver, so we have multiple options.
Indeed, and you can configure your driver in such a way that all the 4 outputs are responding to that single DMX address. So you have a free way of enabling and disabling outputs. So you can make a 4 product with 1 mouse click, a 3 channel product, and with the same mouse click, a single channel product. And you can freely define if you want to use all the outputs or just 1.
So with the same product,
with exactly the same product. With exactly the same product. So originally we had 3 channel DMX products and 4 channel.
Yeah.
The only difference is an output.
Yeah.
But if you can easily turn them on and off, why do you want to maintain 2 products on the shelf? It doesn't make sense.
No, not in these days.
So anymore. That's the reason why the new power drive portfolio only has 4 channel products.
Very.
Do you know a type of cable that is suitable for DMX and that 2 cores that will fit in the eldoLED linear drive 720? You're touching the right point.
Yeah.
I don't know who asked the question, but that's something I ask myself every week when I'm looking into a linear drive 720. Those terminals are really small. But that was because of the fact that we needed to add DALI and DMX and an external input on exactly that same product. So there was no size for a bigger terminal. So what I always recommend customers to do is either using a CAT cable to wire those products, because a CAT cable tends to have smaller cables than a regular RS485 cable. And if that's not possible, use a cable connection box directly next to the linear drive, where you can go in with 2 wires and go with 1 wire to the linear drive. And yes, I know that is a small T-tap, but as long as that T-tap is limited to a few centimeters, it's not influencing the signal a lot. And it helps you to have 2 proper connections in a terminal block and 1 signal cable entering the linear drive. But yes, I definitely understand that question. I can also guess where it's coming from, but I won't mention the name. And indeed, the next linear drive we will put on the market will no longer have those tiny terminals anymore.
And we solved that already, I think, on the new power drive.
Indeed, in the new power drive, we came up with proper connections there.
Good news. Thank you.
Can you elaborate on the impedance values between DMX positive, negative shield in order to properly debug issues and short?
I think this needs a scope or not.
Well, you can do it multiple ways. You can do it with a multimeter device, measure the transceiver impedance between the positive and the shield, and the negative and the shield, and you compare those between units to quickly eliminate
transceiver damage.
But there are multiple ways of doing it. What I always would recommend is simply use a DMX measurement tool. So Swisscom and the guys from City Theatrical having very good DMX test equipment available, which is designed for diagnosing the DMX quality on the line. It can see reflections on the cable, it can see disturbances on the cable, it can provide you a test signal, it can also read out the signal at the end of the line to see if the data is actually there. I would simply invest a few €100 into a proper measurement device designed to do diagnostics on DMX, then try to do it with typical electronic multimeter devices, oscilloscopes, because you need to be really techy to understand that signal in such a way that you can decide, is this correct or is this wrong? So, yes, I have some experience, but I'd rather have that field tool in my pocket, using that for diagnostics, because I know for sure that tool is never lying.
No.
And there are 10, 20 different brands available. Next to the fact you can also do the addressing on those units because of the fact that there is RDM in the protocol as well to set the DMX addresses with that same diagnostic tool.
So investing in such a tool when you are doing DMX projects makes a lot of sense.
It's mandatory. If you don't have such a tool, don't complain when something is not working.
Yeah, you just need that tool. If you buy that tool,
you need it to be able to do it correct. And if everything goes well from the start, you might never need it. But once there is an issue, that device pays itself.
Okay.
Well, you cannot do everything at once.
No.
And what I see, to be honest, from the industry is that the 48-volt track lighting is focusing on DALI.
Yeah.
You need 3 conductors because you need the positive, the negative, and the shield.
And no T-taps.
And no T-taps, indeed. So track lighting is not the best way to do DMX on. You see often wireless DMX luminaires on those track heads.
Possible.
From a component perspective, having small DMX drivers available, to be honest, you see them a lot in the market, but they don't guarantee you the quality as you would expect from an eldoLED product. And I would say, as of today, most customers are relying on our AC products over our DC products. But yes, we're definitely investing research and time into DMX developments. But we're developing for mainstream applications and not developing for specialized luminaires like 48-volt DC track and so on.
Got it. So not on the roadmap yet.
No, there is no particular product on the roadmap as of today that can be put in one of those categories. There's definitely a lot of DMX products in the near future roadmap, but not of the products that we were referring to the question.
Okay.
And if you guys think that we are missing a certain product, do not hesitate to reach out to us. Sometimes we're not even aware of a trend in the market. So just give us a note. The connection of the linear drive 720D is too small for an RS485 DMX cable. That's why we are using Cat6 cable to make a daisy chain. Will the connection of this will be improved? Yes, the DMX standard says that you can use an RS485 cable, and you're also allowed to use a Cat5 or a Cat6 cable. I personally would always use a shielded version, but even an unshielded version is still according to DMX usage standard to be used as a appropriate cable for DMX signal. When I mention a T-tap, it's not good. What do you want to do within eldoLED drivers to do not have a DMX in and out? The terminal is only allowed for 1 wire. That's correct. And that's simply because of a space perspective. So when we were developing this new power drive product, we would only have space for 3 terminals in this product. If we would have used in and out on that same product, we would again have ended up with those tiny, tiny, tiny connectors that we put on the linear drive 720D. So we did want to avoid that. And what I always see as a good practice, if you use a wire for rule, A typical RS485 cable has a wire size of like
Point.
0.34 millimeter.
Even smaller.
Or even smaller, 22, 25
Yeah.
millimeter. You can easily strand those two together and add a wire rule on top of them, because the terminal on the product itself is accepting a 1.5 millimeter cable or a 1 square millimeter cable, including a wire rule. If you put on the wire rule on those two cables, crimp them together, and then put them into the product, it's also easier for wiring because you not have to push two wires in that same terminal at the same time.
Okay.
But we definitely understand it, and if it's an issue, a short part of wire, but a single wire from the driver to your first connection box is allowed according to the standard. But try to minimize the length of the cable.
Does DMX require a special connector between signal wires? Is there any concern about noise?
Well, the industry has standardized only one single connector, and that's an XLR 5-pole connector. And the only reason they did the 5-pole connector there is originally in the standard, they want to have a transmitting cable and a receiving cable, so they needed 5 poles.
Yeah.
That second data pair is never used in practically.
No.
But they maintained that 5-pole connector simply because of the fact that all the microphone audio cables and speaker cables are equipped with a 3-pole connector. And as I explained in the presentation, that is most often a wrong type of cable. So they maintained the XLR 5 to be the industry recognized single, only available to use connector on a DMX signal.
So that's also because that the DMX connector is mostly made of steel.
Yeah.
And that steel housing is also
very
connected.
robust.
And also is connected to shield also.
Yeah,
So that connector
indeed.
itself is working as a shield.
Yeah, the connector itself is fully shielded because of the fact it's metal as well, indeed. But looking into the DMX standard says it's based on RS485. So you can use any connector which is designed for RS485 data signals. No matter if it's an industry recognized XLR connector, it can also be a very small pigtail connector or whatsoever.
Doesn't matter.
As long as it's designed to be used for low voltage RS485, you're fine by using it. But the standard is only referring to the XLR 5-pole connector as to be the used connector, next to the fact that they use the RG45 as an alternative there for use of the CAT cabling. And then also the wiring is standardized. So the first pin of the XLR connector is the data positive, the second one is the data negative, and 7 and sometimes 8 are used as the shielding for on a regular data cable with a Cat5 connection.
Does the PowerDrive 6060, can it be configured with one DMX address to control all 32 luminaires at the same time? So this is more a product specific question. So what could be the answer on this one?
I know the answer. Do you know the answer?
I know the answer that you know the answer.
Ah, great. Okay. Well, the PowerDrive 6060 is equipped with a display.
Yeah.
On that display, it asks you to select the mode. And then you define if it's a DMX, a DALI device, or 0 to 10 or standalone mode. Most of the times it will be set to DMX. If you set it to DMX, it asks you later on, what do you want to use? Do you want to use RGBW? I think that's the default we're using.
Yeah.
Then you get 32 individual addresses. But you can also put it into single color mode. At that moment, they're responding to individual addresses. But to be honest, I do think that the device in that case is in 8-channel mode.
Yeah.
Because if you put it into single, you might think of the fact that it's single for the whole system, but we're actually meaning single output groups. And the device is equipped with single output groups, which is having 4 outputs. So if you put it into single mode, I think the minimum amount of DMX addresses you need on such a device is 8.
But you have 512 channels on a DMX line, and most controllers are easy to configure.
Yeah, but I know by heart that Lutron is limiting in the amount of available DMX channels. So that might be the root cause of this question. And to be honest, I have to verify if we can actually put it into single channel mode from a configuration perspective. But as of today, I think it's 8. But it's a very, very good question.
Do you have a plan to increase the output to 5 or more channels for new RGB double fixture, or are there any more plans to go to ArcNet in the future instead of DMX?
Well, it's actually a very funny question, because if you develop an RGBW luminaire, you only need 4 channels. I mean, an RGBW amber, for example, requires 5 channels. But it might be the case that people are referring to the fact that you want to use a master DIM, but I think they're referring to the fact that you need a 5th output. Yes, we have looked into those applications, but the majority of the applications today is RGBW. And if you have that specific project where you would need 5, 6, 7, or maybe even 8 channels, you can easily combine 2 drivers into that same fixture, put one on address 1, put the next one on address 5, and they will act as a 5, 6, 7, or 8 channel product. And that's how we most of the times deal with the 5 channel, 6 channel, 7 channel luminaires.
Yeah, because of all those channels also could have different power levels. So sometimes it makes more sense to add 2 drivers instead of 1 big driver, more efficient.
It requires size in a product. The products are also fairly big, so they will even be bigger in that case. Next to the fact that in 80% or even more applications, you don't need that 5th or 6th or 7th channel. So I would rather use 2 products instead of having a 5 channel product where I never use that 5th channel. But
got it.
Regarding to the question on ArcNet, that's definitely a good question. There is a difference between ArcNet and DMX, because DMX is designed to be the signal going to the luminaire. And ArcNet and streaming ACN and even secure streaming ACN, those networks are designed to be transported over regular TCP/IP network interfaces. So they're mainly used for building level of signal distribution. And at the endpoints where the luminaires are connected, most of the times people place over there a converter that converts the ArcNet into a physical DMX line. You would hardly see any drivers today acting as true ArcNet drivers.
It can happen that when the ArcNet driver fails, it will disrupt the complete system.
Yeah, and it's also pretty priced and pretty expensive as well to have a TCP/IP interface on each individual LED driver, next to the fact that you need to run your network cable inside the fixture. So for big moving heads, which are requiring a lot of channels, sometimes even 128 DMX channels, it makes sense to go to ArcNet. For individual RGBW drivers, I think it doesn't add any value to go directly with ArcNet into an LED driver.
Got it. Good question. Thank you. Next question is, are you planning to develop a driver that can be controlled with a pulse switch to do switch on and off dimming? Are we now talking about a 1-channel, 2-channel driver, or 4-channel? I would guess it's a 1-channel driver.
I think people are referring to a 1-channel driver, because pulse dimming is mainly referred to as a 1-channel driver.
Yeah.
And what we did in the last 6 months, we launched a lot of products, our existing DALI products, to support pulse dimming. You can see that from that pulse logo on the driver label. Those products are supporting a pulse on the DALI input. So you can use a regular momentary switch having 230 volts on that cable. You put the 230 volts line voltage into the DALI terminal. So line and neutral will be put into DALI positive and negative. And then you can control those products by simply a push of a button. That's what we call pulse dimming. Pulse dimming is available on a select amount of DALI products today. Out of my head, it's 20 watt, it's 30 watt, and 50 watt drivers with a strain relief. So the A-type products, which are available with pulse dimming already.
So if you go to our website, there's a product finder application running on that. You can select pulse dimming. There you can see exactly what products we have available as of today. What is the difference between DMX and DALI? Well, that's a good one.
We had a fairly good webinar 2 weeks ago explaining everything about DALI.
Yeah.
And 2 months ago, we did the same session explaining everything on DALI.
Yeah.
And then we discussed ourselves like we need to do the same for DMX.
Yeah.
But DMX tend to be complex.
Yeah, it is.
So what's the difference between DMX and DALI? There are 2 different types of protocols.
So
one is designed for mainstream lighting. One is designed for architectural and entertainment lighting. So DMX tends to be more the entertainment industry. DALI tends to be more the general lighting applications. They both have their pros and cons.
Yeah.
Is there a favorite? No, it's a matter of taste.
And application.
And application.
Application.
So the difference, yeah, DALI is easier from a wiring perspective, but is not as versatile from a protocol perspective.
And speed.
And speed, indeed. If you want to have high dynamic transitions and so on, DMX is probably preferred over DALI. But if it's just on-off and dimming from a few luminaires, DALI may be good as well.
Yeah.
And they both have their market share in the market. They will always be next to each other.
Absolutely.
There is no replacement. DALI is never going to replace DMX, and DMX will never going to replace DALI.
So just the two topics: 512 channels for DMX, 64 addresses or channels on DALI, and the wiring is also different.
Yeah.
That's the DALI wiring is simpler and more robust than DMX.
Indeed.
That's one thing that is absolutely true. What is RDM? That's a good one. I think it's the abbreviation of remote device management, and I think it's a subset of language in DMX.
Yeah, the DMX signal is from the controller to the luminaires. But as I explained, and I can briefly zoom back to that slide just to show it to you. Hold on, where is it?
It's the data train, I guess.
It is the data train indeed, where I want to go back. You have an idle time. So if you have the signal, all 512 channels, after that 512 channels, there is a moment on the line where all the signals are silent. In that moment in time, you could make use of the functionality that you ask a luminaire in the data train a certain command or a certain question, and that particular luminaire is answering in that idle frame of the DMX time.
Okay, so that's a two-way communication then.
Indeed. It can be used to address a luminaire, to set the DMX address. It can be used for temperature readouts. It can be used to read out if a driver is a one-channel device or is a four-channel device. So if it's single color, if it's RGBW, you can read out the brand name, you can read out the functionalities that it's supporting. That's what you do on RDM, and that's an additional layer on top of DMX. And especially because of that RDM, the cabling becomes important because the reflections you get on the line might interfere on that same moment when the luminaire is trying to answer back to the control system.
So okay, so when you run into RDM issues, it's giving you the signs that you can have issues with DMX lines.
If your DMX line is not wired in the correct way, the first thing you will notice is that your RDM functionality is no longer working. Before your luminaires even start blinking or randomly flashing.
Okay.
At that moment, your RDM is probably already no longer working.
Okay, got it. Makes sense. So this was the last question, and I would like to thank Stefan for his great explanation. I would like to thank Mark Kramer for doing the production. I would like to thank you all as attending this session, and please feel free to ask questions via email, drop us a chat, drop us an email, and don't forget to like us on LinkedIn. See you next time.
Bye-bye.